This is Unit 11, Lesson 4, Arithmetic and Geometric Sequence Word Problems. The main thing here is to understand that these are going to be sequences, so we're going to use the same two formulas that we've been using so far in this chapter. For arithmetic, and you have an arithmetic sequence when you have a D or a common difference, you're adding to get to the next number. A sub n, the nth term, is equal to a sub 1, the first term, plus n minus 1, n being the term number, and d is our common difference times d. For a geometric sequence, we're talking about the formula being a sub n, the nth term, is equal to a sub 1, the first term, times r, the common ratio. That's what you multiply by to get to the next number. And that's to the n minus 1 power, where n is the term number that you're looking for. So again, the best way to do this is to just get into some problems. So that's what we're going to do. As you read through the problem, what you're going to try to do is develop a sequence from that and then answer the question that they're asking. The sum of the interior angles of a triangle is 180 degrees, of a quadrilateral 360 degrees, and of a pentagon 540 degrees. Assuming this pattern continues, find the sum of the interior angles of a dodecagon, which is a 12-sided figure. Well, if you think about what they've given you here, they have given you several different terms in this sequence. The first term is 180 degrees, the second term 360, and the third 540. In this sequence, it's really important to understand that a triangle has 3 sides, a quadrilateral has 4 sides, and a pentagon has 5 sides. They are asking us to find the sum of the interior angles of a dodecagon, which is a 12-sided figure. Now, what you have to understand here is that each of these side numbers, there are 2 more sides than the term number that we're dealing with. Understand, this 180 is the first term. This is the second term. This is the third term. So we're trying to figure out one of the terms on down the road here, but we know that the first term has 3 sides, the second term has 4 sides, the third term has 5 sides. So it looks like we have 2 more sides than the term number. So if we're looking for a 12-sided figure, the term we're looking for has 12 sides, so that means our term number would be 10, because the term number is 2 less than the number of sides. See, the first term has 3 sides, the second term 4 sides, third term 5 sides. A common mistake for this is people would try to find the 12th term. That's a common mistake. But what we're actually trying to find is the 10th term. And we need to ask ourselves, is this sequence an arithmetic or a geometric sequence? Well, if you look at what's happening here, aren't we adding 180 to get to the next term each time? So I would say this is arithmetic. So I'm going to use the formula a sub n equals a sub 1 plus n minus 1 times d. A sub n is going to be the 10th term. A sub 1 is the first term, 180. We're looking for the 10th term, so 10 minus 1 will be 9. And our d is 180. I would go into Desmos, put that in Desmos, and solve it. So in Desmos, if I put that in, 180 plus 9 times 180 gives me 1800. So my answer here, a sub 10, the 10th term, is 1800. That means that the sum of the interior angles of a 12-sided figure is 1800 degrees. In the second one, it says, after surgery, your trainer tells you to return to your jogging program slowly. He suggests jogging for 12 minutes each day for the first week. The next week, he wants you to add 6 minutes to your jogging time, adding 6 minutes each week, gradually increasing the jog time. On what week would you be jogging 60 minutes per day? Well, it says on the first week, you start jogging 12 minutes. In the next week, you add 6 to that. So the next week, 18 minutes. The following week, 24 minutes. And we will continue that pattern. We want to know how long it's going to take until you are jogging 60 minutes per day. Well, you could use a formula for this, or you could just continue this sequence. You could do it either way. This is arithmetic, so the formula is a sub n equals a sub 1 plus n minus 1 times d. In this one, we don't know what n is. We're looking for the term number because we're looking for how many weeks it takes to get up to 60 minutes per day. We know that a sub n can be one of two things. It can be the nth term, or it could be the last term in the sequence that we're talking about, and that's what it is in this case. A sub n is the nth term or the last term in the sequence that we're talking about. So a sub n is going to be 60. A sub 1 is the first term, 12. We don't know what n is, but we know that d is 6. We're adding 6 to the time that you're jogging each week. So if I simplify this, I've got 60 equals 12 plus 6n minus 6. 12 minus 6 is 6. If I subtract 6 from 60, I get 54. And then if I divide by 6, I get n equals 9. So it will take 9 weeks to get to where we are jogging for 60 minutes per day. A culture of bacteria doubles every 2 hours. It doubles. Now you have to think about that. What does double mean? When I think about doubling something, I'm going to think about multiplying that thing by 2. So if it doubles, we're multiplying by 2. That right there tells me this one is a geometric sequence. If there are 500 bacteria at the beginning, how many bacteria will there be after 24 hours? Now it doubles every 2 hours. This is important as well because a lot of people make the mistake. They see this 24 here and they think we're looking for the 24th term. That's not quite right because it's doubling every 2 hours. So if you think about this one, there are 500 at the beginning. It doubles every 2 hours. So in 2 hours, we would have 1,000. So that's at time 0. So that's at the beginning. After 2 hours, we have 1,000. After 4 hours, we have 2,000. After 6 hours, we have 4,000. And this pattern is going to continue until we are at the 24-hour mark. First term, the second term, the third term, the fourth term is at 6 hours. We need to figure out what term number this one would be. I think the easiest thing to do here is just to figure out how many blanks it would be. So this is our first term. We know that's 500. The second term is at 2 hours. Third term, 4 hours. Fourth term, 6 hours. Then 8, 10, 12, 14, 16, 18, 20, 22, 24. So we've got at 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24 hours. You could count the number of terms here to figure out what the term number is you're looking for to figure out what this would be. So we're really looking for the 13th term. You could use the formula a sub n equals a sub 1 times r to the n minus 1 and plug it in. So a sub n, or a sub 13, we're looking for the 13th term, is equal to 500 times r. R was 2. We're multiplying by 2 to get to the next term. And then n is 13. So 13 minus 1 would be 12. I would then go into Desmos. 500 times 2 to the 12th. That gives me 2,048,000. So if I go here, I have 2,048,000 bacteria in the sample. Miners discover an ore sample containing 500 milligrams of radioactive material. It is discovered that the radioactive material has a half-life of 1 day. Find the amount of radioactive material in the sample at the beginning of the 7th day. So if you're thinking about what this pattern is telling us, the first day we have 500 milligrams of a radioactive material, and that material is decreasing. Its half-life is 1 day. So this is day 1. At the beginning of day 1. At the beginning of day 2, we have 250. We're dividing this by 2 each day, which means we're multiplying by 1/2. So the definition of a geometric sequence, our R value is what we multiply by. So if we're dividing by 2 to get the half-life amount, then we're really multiplying by 1/2. By the third day, so that's day 2. By the third day, we're at 125. And this pattern continues. They're asking us to find how much is in the sample at the beginning of the 7th day. So we're looking for n equals 7, the 7th term of this sequence. Our geometric sequence formula is a sub n equals a sub 1 times r to the n minus 1. Our a sub n is what we're looking for. We're looking for the 7th term, so we're looking for a sub 7. A sub 1 is 500. Our r is 1/2. And our n is 7, so 7 minus 1 is 6. I'm then going to go into Desmos and type that in. This one is 500 times 1/2 to the 6th power, 7.8125. And I could go over here and get it as a fraction if I want. There's nothing wrong with the decimal there. I'll just leave it like that, 7.8125. But I want to make sure you understand, Desmos will now convert decimals as long as they're terminating decimals. It will convert them to fractions for you, which is nice if you need that. So we've got 7.8125 as our 7th term, and that would be milligrams. Frank has taken a job with a starting salary of $15,000 and annual raise of 4%. What will his salary be during his 3rd year on the job? Okay, so this is the 1st year on the job, 2nd year on the job, 3rd year on the job. For something like this, I'm not going to use a formula. We're only looking for the first 3 terms. So a formula is going to make this more difficult. What you really need to understand, though, is how does this affect our R value? Because you have to get an accurate R value if you're going to have any chance of getting this right. Well, if he's making $15,000 his 1st year, wouldn't that be 100% of his salary? That's what he makes. If that salary is going up by 4% each year, that's his annual raise, well then wouldn't this next salary be this percentage plus 4%? So wouldn't he be making 104% of what he made the 1st year? So what I'm going to do is I'm going to multiply this $15,000 by his new percentage rate, or the percentage rate of his next year. Next year, not only does he make 100% of his salary, he makes 4% more than that. So next year's salary is what I get when I multiply 15,000 by 104% as a decimal. So my rate is 104%, so my R value here is going to be 1.04 because he's making over the 100% that he made the 1st year. So if my R value is 1.04, what I need to do is multiply by 1.04 to get each next year's salary. So I'm going to go into Desmos and I'm going to put in the $15,000 salary and I'm going to just multiply that by 1.04. And that gives me $15,600. In the next box, I'm going to take the 2nd year's salary, $15,600, and multiply that by his rate, which is 1.04 again. It's going up by 4% every year. So his 3rd year's salary is going to be $16,224. And you could fill in that 2nd year salary as well if you'd like. But that's what our answer is for this problem. $16,224 is what he would make his 3rd year on the job. A new pair of running shoes costs $70 now. Assuming an annual 8% price increase, find the price 4 years from now. Again, this one there's no need to find a formula. I mean, you could, but we're going to just write out the first 4 terms to get our answer. They cost $70 now. They are increasing 8% each year. They want the 4th year amount. So this is the 1st year, 2nd, 3rd, 4th year. So they want the 4th term. Well, if this is 100% of the price and it's increasing by 8% per year, our R value is that 100% plus 8%, or 108%, which is, as a decimal, 1.08. That is our R value. So we're going to multiply each term by 1.08 to get the next term. So I'm going to go into Desmos. I'm going to put in the original price, and I'm going to multiply that price by our R value, 1.08. That gives me 75.6 for the 2nd year. For the 3rd year, I'm going to take that price, 75.6, and multiply it by 1.08 again, because that's the rate of increase every year. That is 81.6. I'm going to say 81.65 because I'm going to round to the nearest penny. So the third term is 81.65, and I guess technically here I should have put 75.60, 60 cents. And then I'm going to multiply that answer, 81.65 times 1.08 a third time. When I round this number, I get 88.18, rounding to the nearest penny. Always make sure when you're dealing with money, you round to the nearest penny. And rounding to the nearest penny means you round to 2 decimal places. You rent an apartment that costs $1,200 per month during the first year, but the rent is set to go up 12% per year. What would be the rent of the apartment during the 6th year of living in the apartment? Round to the nearest cent. Your rent is $1,200 per month. We are looking for the 6th year. So that's the first year, 2nd, 3rd, 4th, 5th, 6th. And again, since we're dealing with money, we're going to round this to the nearest penny. I think this one's just as easy to use a formula for. This is a geometric sequence because we're multiplying to get to the next amount. This right here, the $1,200, is 100% of your rent the first year. It's going up 12% per year. So next year's rate, we're adding 12% to give us 112% of what we're paying this year. So that means our R value is 112% as a decimal. So that's 1.12. So to get to the next term, we will multiply by 1.12. I'm going to use the formula this time. A sub n equals A sub 1 times R to the n minus 1. I will round to the nearest penny. A sub n, I'm looking for the 6th year. So this is the 1st, 2nd, 3rd, 4th, 5th, 6th year. So I'm looking for A sub 6. We know A sub 1 is 1,200. We know that R is 1.12, 112% as a decimal. N is 6, so 6 minus 1 is 5. I'm going to go into Desmos. My original rent is $1,200. I'm going to multiply that by 1.12, the rate of increase each year. And I'm taking that to the 5th power. That gives me 2,114.81. So my 6th year rent would be $2,114.81. That's how much rent I'm going to be paying on the 6th year if I stay that long in this apartment. If I were paying that much rent, I think I'd look into buying a house. Jan invested $1,000 in an account that pays 5% interest compounded annually. Assuming no deposits or withdrawals are made, find how much money Jan would have in the account 14 years after her initial investment. Round to the nearest cent. All right, so she invests $1,000 in an account and it pays 5% interest compounded annually. So basically what that means is this is 100% of the money she put in. Every year she's earning a 5% interest. So that means the amount of money in the account is going to be 105% of what she had in there the previous year. They want to know how much money Jan would have in the account 14 years after her initial investment. So this is a geometric sequence. A sub n equals A sub 1 times R to the n minus 1. We're looking for the 14th term of this sequence. A sub 1 is 1,000. Our R value is 105%, which is that as a decimal, so 1.05. N is 14, so 14 minus 1 is 13. So I go back to Desmos and I put that in. 1,000 times 1.05, that's your percentage as a decimal, to the 13th power. And that gives us $1,885.65 if I round that to the nearest cent. So in the 14th year, Jan will have $1,885.65 in her account. So hopefully this gives you everything you need to be able to do these word problems. It should be fairly straightforward. I don't look for this to cause you a whole lot of problems. They're not trying to trick you with these. It's basically just plugging into a formula, finding a particular term, and that will be your answer. Maybe for some of you, the trickiest part might be the rounding and making sure you're being very careful about what you are getting for your answer.